Hello, you absolute legends, and welcome back to Create Inc. In today's video, we are going to use a 3D printer to better the lives of animals around us and also of the people who treat them. The problem we are trying to solve today is the fact that giving IV drips to medium and large animals is a bit of a tricky process. When you give an IV to a human being, he, she, they would stay still and make sure the IV needle doesn't fall out or move a lot. That's not the same with animals. They're going to move, and that causes a lot of problems for the animal itself and also the people treating them. Today, we take a look at a simple 3D printable solution for this problem. Now, before we start the video, I'd just like to say that on this channel, I try to bring original content to you. I do everything from scratch, be it the graphics, the animations, or even the music. So if you've been enjoying my videos, please hit the like button for the algorithm and subscribe to not miss out future content. A little bit of context for today's video. Both my parents have dedicated their lives to treating animals, and between them they have over 5 decades of experience as veterinarians, with specializations in veterinary medicine and veterinary microbiology. My mother came up to me with a problem that could possibly have a simple solution, but for some reason no one had quite tried to solve it in a cheap and efficient manner. The problem being that it's really difficult to have an IV drip stay in place without need for supervision on animals. So before we get into the meat of today's video, it's very important to understand a few terminologies. Here is the structure of a typical mammalian skin: the epidermis, dermis, and the subcutaneous layer at the bottom, which also contains blood vessels, out of which only a single vein is shown here. We'd be talking about two types of fluid administration methods. The first one, called an intravenous administration, that injects the fluid right into the veins, also called as IV. The other one being subcutaneous administration, that injects the fluid into the subcutaneous layer of the skin, also called subcut. This applies to most mammals, including human beings. Different types and volumes of fluids are administered differently. Some should be intravenous, some should be subcutaneous. Typically, a large volume is administered using IV drips, and small volumes are subcuts. As I already explained in the introduction, the problem is that animals don't stay still once an IV drip has been started. This causes 3 problems. Discomfort for the animal. The needle might dislodge itself and fall out, which would cause wastage. But the biggest one might still be that the needle dislodges partially and goes into the subcutaneous layer, and the fluid would accumulate there and cause swelling, pain, and it would become really difficult to reinsert the IV drip on the swollen neck. Now, there are some commercially available products that might alleviate these problems, like these cannulas. You insert it with the needle, you take the needle out, and the flexible cannula stays inside. The problem with this is still that it doesn't completely mitigate the risk of the cannula falling out. And there is also a problem of cost, since the cannula would have to be disposed of after a single use. And at first I thought, a tape might work. That was my first thought when I started working on this project. But I soon realized that masking tape or plaster doesn't stick well to animal skin, especially since there is a lot of hair. So what did I finally come up with? A few 100-year-old tech, if not a few 1,000-year-old tech, a clip. I call this the MLIP project, which stands for Medium and Large Animal IV Clip, because it also has this lip over here. I know it's not a perfect acronym, feel free to suggest better names in the comments. So it's a fairly straightforward device. There is this part that is pressed onto the needle and clicks into place and holds it there. The other end has some teeth that press against the skin of the animal and provide resistance to being pulled. Don't worry, these teeth are made of plastic and they really won't hurt the animal. They're not sharp enough to scratch or cause lacerations. The usage for the MLIP is really simple. Once the IV drip has been started, you take the clip, you press it against the needle until it clicks into place, and you're done. I know it seems like a really nothing solution, but honestly I did go through a few different prototypes before I landed on this. And this thing is actually the kind of solution that I really enjoy as an engineer. Does the job, cheap to produce, easy storage, easy to use, and durable. And since it does not go into the body, it should be reusable if used with proper and well thought out protocols. We did a few tests on cows, buffaloes and sheep, and testing is still ongoing. Here's a simple demonstration of how the clip is used. Please make sure that the animal is in a halter before you put the MLIP on, so that the rope does not interfere with the MLIP. You insert the IV needle as you usually do, and then start the drip. You take the MLIP and make sure that the latch is on the hub of the needle and just click it into place. You would see that the MLIP clings to the skin of the animal. And here is the removal process shot on a different animal. We have also found a lot of success testing this on sheep because they have wool and the MLIP clings really well to the wool. If you find that the grip of the clip is inadequate for your usage, you can use a thread and pass it through this loop over here, and you can attach the thread to a clip and then you can clip it onto the hair or the skin of the animal. I would like to emphasize that this is still in testing, and I do invite any veterinarians watching this video to download the STL files available in the description and to test it out for themselves. Please reach out if you think some aspects of the clip need further refinement. With that, we come to the end of yet another video. The STL files for the clip are in the description. There is one link for Etsy and the other one for Thingiverse. They are the exact same file. If you'd like to support the channel, you can get it from Etsy for $1. Otherwise, it's available on Thingiverse for free. You would also find some other artwork and animations available on my Etsy store, like this clip art of a 3D printer that I made, or this fully animated and scripted After Effects project that shows how CMYK color works. If you liked the video, you know what to do. And if you didn't, the other one works fine. Leave your inputs and ideas in the comment section down below. I really read them. Subscribe for original and innovative content. And until next time, just keep building.